the solutions from exercise 2.2 from the chapter Polynomials. So in the first question, they've asked us to find the zeros of the following quadratic polynomials and verify the relationship between the zeros and its coefficients. So first we need to find the zeros of the given polynomial by the splitting of the middle term method. So we need to find two numbers in which the sum is -2 and the product is -8. So the sum of the two numbers that we're going to find need to equal -2 and the product of the two numbers need to equal -8. One such pair of numbers would be -4 times 2. So when you multiply -4 times 2, you'll get -8, and when you add -4 plus 2, you'll get -2. So we're going to substitute these two numbers over here. So we're going to rewrite the first equation as x squared minus 4x plus 2x minus 8. So now we're going to split both of these numbers. So first we're going to take the common term, which is x outside. So when we take x outside, inside the bracket we'll get x minus 4. We're going to do the same thing over here, so we're going to take 2 as the common number outside. So plus 2, we're going to take it outside, and inside the bracket we'll be left with x minus 4. So when you multiply the number outside the bracket within the brackets, you need to arrive at the first beginning equation. So you'll get x squared minus 4x plus 2x minus 8. So now the zeros, the factors of this equation will be x minus 4 is equal to 0 and x plus 2 is equal to 0. Now we can say that the value of x can be 4, or the value of x can be -2. We're going to take the value of alpha as 4 and the value of beta as -2. They've also asked us to verify the relationship of the zeros and the coefficients. We know that the sum of the zeros, or alpha plus beta, is equal to minus b by a. And the product of the zeros, alpha, beta, is equal to c by a. So now we're going to add the sum of the zeros, which will be 4 minus 2, which needs to be equal to negative b. The value of b is 2. The value of b in this equation is -2 by a, which is 1. So 4 minus 2 is equal to 2, and since there's a negative outside the bracket, if there's a minus sign outside the bracket, minus into minus becomes plus. So 2 is equal to 2, hence we have proved this. Now when we multiply the zeros, which is 4 times -2, it needs to be equal to c. The value of c is -8, and the value of a is 1. So when you multiply 4 times -2, you'll get -8, which is equal to -8, and hence we have proved the relationship. The next equation is 4s squared minus 4s plus 1. So in order to split the middle term, we need to find two values in which the sum of the two numbers is -4 and the product of the two numbers is 4. So two such numbers can be -2 and -2. So when we multiply -2 times -2, you'll get 4, because minus into minus is plus, and when you add it, when you add -2 and -2, you will get -4. So we can now rewrite the first equation as 4s squared minus 2s minus 2s plus 1. So now we're going to take the common terms outside. We can see that 2 is common to both of these numbers as well as s. So we're going to take 2s outside, and inside the bracket we'll be left with 2s minus 1. Similarly, we're going to take, since there are no common terms, we're going to take -1 outside. So if we take -1 outside, inside we'll be left with 2s minus 1. The reason why it is minus here is because we need to ensure that when you multiply the number outside the bracket and inside the bracket, we arrive at the same equation that we had before. So when we multiply -1 times -1, you'll get +1, which is what it is here. And we also need to ensure that the values inside the bracket, the two values inside both the brackets need to be equal. So to ensure that our answer is right, we need to make sure that the values inside both brackets are equal. So the two factors of this quadratic equation will be 2s minus 1 is equal to 0 and 2s minus 1 is equal to 0. So now we can observe that it has equal roots. For this quadratic equation has equal roots. So the two roots of this equation will be s is equal to +1 divided by 2, as we're bringing -1 over to the right hand side, and 2, which is multiplication, becomes division when it is brought over to the right hand side. So s is equal to 1 by 2. So now we need to prove the relationship of its coefficients and its zeros. So we're going to take alpha as 1 by 2 and beta as 1 by 2 because this equation has equal roots. So when we add the two roots, alpha plus beta, we need to get minus b by a. And when we multiply the two roots, we need to get c by a. We know that a is equal to 4, b is equal to -4, and c is equal to 1. So when we add 1 by 2 plus 1 by 2, we will get, you put the negative outside the bracket, and -4 divided by 4. So 1 by 2 plus 1 by 2 will equal 2 by 2, which is equal to 1, which is equal to 4 by 4, which is also equal to 1. So hence we have proved that the sum of the zeros is equal to minus b by a. Now the product of the zeros, which is 1 by 2 times 1 by 2, we need to prove that it is equal to c by a. We know that c is 1 and a is 4. When you multiply 1 by 2 times 1 by 2, you'll get 1 by 4, which is equal to 1 by 4, hence proved. In the third equation, the given quadratic equation is 6x squared minus 3 minus 7x. We'll notice that this equation does not follow the formation of a quadratic equation, which is ax squared plus bx plus c. So we need to rearrange this equation so that it satisfies the quadratic equation. So when we rewrite it, we need to make sure that 6x squared minus 7x minus 3 is equal to 0. Now we need to find two numbers in which its sum is equal to -7 and its product is equal to minus 18. Because 6 times minus 3 is minus 18 and the middle term is -7. So the two numbers can be 9 times 2. It can be -9 times 2, which will give us minus 18, and -9 plus 2 will give us -7. So now we can rewrite the equation as 6x squared minus 9x plus 2x minus 3. So now we're going to take out the common numbers for the common terms from both of these numbers, which would be 3x. We're going to take outside the bracket, and inside the bracket we'll be left with 2x minus 3. In the second term, we'll notice that there are no common terms, so we're going to take +1 outside, and inside the bracket we'll be left with 2x minus 3. we'll notice that the values inside the brackets are same so we can assure that our answer will be right. So the factors for the equation will be 3x plus 1 is equal to 0 and 2x minus 3 is equal to 0. So when we bring over, we need to isolate the x, so when we bring over plus 1 to the other side, it becomes negative 1. So we can say that x is equal to negative 1 over 3 and x is equal to positive 3 over 2. So we're going to take the value of alpha as minus 1 by 3 and beta as 3 by 2. When we add alpha plus beta, we need to get minus b by a. And when we multiply it, we need to get c by a. We know that the value of a is 6, b is negative 7, and c is negative 3. When we add minus 1 by 3 plus 3 by 2, we need to get plus 7 over 6. So since both of these fractions do not have a common denominator, we're going to make sure that they both have a common denominator so that we can add both of the terms. So we'll get negative 2 plus 9 over 6, which needs to be equal to 7 by 6, because minus into minus becomes plus. So 9 minus 2 is 7 by 6, which is equal to 7 by 6, hence it is proved. Next, when we multiply minus 1 by 3 times 3 by 2, we need to make sure that the answer is negative 3 over 6, which is also equal to minus 1 by 2. So when we multiply these two numbers, we'll get minus 3 over 6, which is equal to minus 1 by 2, because when we simplify this, you'll get minus 1 by 2 is equal to minus 1 by 2, hence proved. In the fourth question, we've been given the equation 4u squared plus 8u is equal to 0. We know that the form of a quadratic equation is ax squared plus bx plus c. And we can notice in the given equation, the value of c is missing, so we're going to take that as 0. However, we can also notice that both of these terms have a common term that we can take outside. So that is what we're going to do. So we can see that 4 is common to both of these terms, as 8 is a multiple of 4, and there's also u, which is common to both of these terms. So we're going to take out the common terms outside. So when we take out the common terms, you will be left with 4u is going to be taken outside of the bracket, and inside we'll have u plus 2, which is equal to 0. So when we multiply 4u times u, you'll get 4u squared plus 8u. So now the two zeros of this equation will be 4u is equal to 0 and u plus 2 is equal to 0. So in order to isolate the u, we bring 4 over to this side. So we know that any 0 divided by any number is equal to 0, and u is equal to negative 2. So the two zeros of this equation is 0 and negative 2. We're going to take the value of alpha as 0 and the value of beta as negative 2. Now when we add alpha plus beta, we need to get negative minus b by a, and when we multiply alpha times beta, we need to get c by a. We know that the value of a is 4, the value of b is 8, and the value of c is 0 because it is not given. When we add 0 plus 2 plus negative 2, we need to get minus b by 4. So 0 plus minus 2 is equal to minus 2, and minus 8 over 4 is negative 2, hence it is proved. Now when we multiply 0 times negative 2, we need to get c. We know that the value of c is 0 over a, which is 4. We know that 0 multiplied by any number is 0, and 0 divided by any number is 0. Hence, 0 is equal to 0, and then proved. In the fifth question, we've given the quadratic equation t squared minus 15 is equal to 0. This is not in the usual form of a quadratic equation, so we're going to solve this differently. So we're going to bring minus 15 over to the right hand side, so you'll get t squared is equal to 15. And when you're going to bring the square over to this side, which becomes square root, so we can say that t is equal to square root 15, which is also equal to plus or minus root 15. So the two roots of this equation are plus root 15 and negative root 15. The value of a is 1, the value of b is not given, so we're going to take that as 0, and the value of c is negative 15. We're going to take the value of alpha as root 15, and the value of beta as negative root 15. When we add root 15 plus minus root 15, we need to get negative b by a. Since the value of b is 0, we know that root 15 minus root 15 is equal to 0, and we also know that the value of b is 0, so 0 divided by 1, which is equal to 0, so 0 is equal to 0, hence proved. When you multiply root 15 times minus root 15, we need to get c by a. We know that root 15 times minus root 15 is equal to negative 15. We know that the value of c is minus 15 and the value of a is 1. So minus 15 is equal to minus 15, hence proved. In the sixth question, we've given the equation 3x squared minus x minus 4. So we're going to use the splitting of the middle term method. We need to find two numbers in which the sum needs to be equal to minus 1 and the product needs to be equal to negative 12. So the two numbers that we can take is negative 4 and 3. When you multiply negative 4 times 3, you'll get negative 12, and when you add negative 4 plus 3, you'll get minus 1. So now we're going to rewrite the first equation as 3x squared minus 4x plus 3x minus 4. So now we can see that there are no common terms except 1 and x, so we're going to take x outside and we're going to be left with 3x minus 4, and similarly over here the common factors is 1, so we're going to take plus 1 outside, and inside we'll be left with 3x minus 4. So the two factors of this equation will be x plus 1 is equal to 0 and 3x minus 4 is equal to 0. So we can say that x is equal to negative 1 and x is equal to plus 4 by 3. So when we add these two zeros of the equation, we need to get, when we add minus 1 plus 4 by 3, we need to get minus b by a, which is equal to plus 1 by 3. So since this does not have a common denominator, we're going to multiply both the numerator and the denominator by 3. So you're going to get minus 3 plus 4 by 3, which is equal to 1 by 3. We know that 4 minus 3 is equal to 1, so 1 by 3 is equal to 1 by 3, hence proved. Now, when we multiply negative 1 times 4 by 3, we need to get c, which is minus 4 by 3. We know that minus 1 times 4 is minus 4, by 3, which is equal to minus 4 by 3, hence proved. The second question, we're asked to find a quadratic polynomial, each with the given numbers as the sum and the product of its zeros respectively. So they've said that 1 by 4 is its sum of zeros and negative 1 is the product of its zeros. We know that in order to find the quadratic equation, if the sums and zeros of the quadratic equation are given, it can be written as x squared minus alpha plus beta plus alpha beta. And they've given that the value of alpha plus beta is the first number of the pair and the product of alpha beta is the second number, negative 1. So we're going to substitute these values in this equation. We're going to get x squared minus 1 by 4 x plus negative 1. We can further simplify this by making sure that it has a common denominator. So we're going to multiply both of these with 4. So you're going to get 4x squared minus x minus 1. So when we bring 4, since all of these terms have 4 as its common denominator, we can bring this over to the right hand side, and we know that 4, any number multiplied by 0 is equal to 0. So 4 times 0 is equal to 0, hence this will be the simplified quadratic equation. In the second question, the value of alpha plus beta is root 2 and the value of alpha beta is 1 by 3. Substituting that in this equation, we'll get x squared minus root 2x plus 1 by 3. In order to ensure that the quadratic equation is simplified, we're going to multiply the numerator and the denominator of the first two terms with 3 so that this equation has a common denominator. This denominator, when brought over to the right hand side, it becomes 0. So we can say that x squared, 3x squared minus 3 root 2x plus 1 is equal to 0, which is the final quadratic equation. The third question, they've given the sum of zeros is 0 and the product of zeros is root 5. So we can say that x squared minus alpha plus beta, which is 0, x plus alpha beta, which is root 5, is equal to 0. And 0 multiplied by any number is 0. We can say that x squared plus root 5 is equal to 0, which is the quadratic equation for the third question. In the fourth question, they've given that the product and the sum of zeros are both 1. So substituting that in the equation, in this equation, we're going to get x squared minus 1x plus 1 is equal to 0. So the final quadratic equation will be x squared minus x plus 1 is equal to 0. The fifth question, the sum of zeros is negative 1 over 4 and the product of the zeros is 1 by 4. So x squared minus 1 by 4 x plus 1 by 4 is equal to 0. Minus into minus becomes plus. So x squared plus 1 by 4 x plus 1 by 4 is equal to 0. In order to simplify the quadratic equation, we're going to multiply this, both the numerator and the denominator, which is 1 by 4. So we'll get 4x squared plus x plus 1 is equal to 0 because we bring 4 over to this side, which becomes 0. In the sixth and final question, the sum of zeros is 4 and the product of zeros is 1. So you'll get x squared minus 4x plus 1 is equal to 0. So x squared minus 4x plus 1 is equal to 0, which is the final quadratic equation for the sixth question.